Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over section 1.2a of our virtual AP Calculus text. We're going to be looking at how to find limits of piecewise defined functions. For more tutorials and support resources to help you pass the AP Calculus AB exam, do visit our website at math.serve.com. Before we get started with the examples, let's do a real quick review on the procedure for evaluating finite limits. We went over this in the previous presentation in our installment. So what we talked about in the previous presentation is that when you are evaluating finite algebraic limits, you use the Sally procedure. We describe Sally as being: first, you substitute. When you carry out that substitution of what x is approaching into the function, you can get an answer, a defined output. You can get an undefined output, which indicates that the limit does not exist, or you could end up with an indeterminate form, which is 0 over 0. 0 over 0 is one of the indeterminate forms. There are other indeterminate forms. But for the scope of this course, we just focus on 0 over 0. So whenever you have 0 over 0, you use algebraic manipulation or L'Hopital's rule to address that situation. Okay? So in the presentation we're going to be looking at today, we're just going to focus mainly on the first step, which is substitution in the evaluation of limits. Another point that we highlighted in the previous tutorial concerning double-sided limits is that when you're looking for double-sided limits, the condition in order for the double-sided limit to exist is that the left-hand limit and the right-hand limit have to be equal. Okay? So when the left and right-hand limits are equal, that value that they're both equal to is going to be the double-sided limit. But if you have a situation where the left and right hand limits are different, then the double-sided limit does not exist. Okay? So keep that in mind as we walk through the examples in this presentation. Alright, let's take a look at question 1. The instructions are for us to evaluate the given limits. So problem 1, let's say we have to evaluate the limit as x approaches 1 of f of x, where f of x is the piecewise defined function given by negative x plus 1 for the subdomain x is less than 1 and negative 2x minus 1 for the subdomain x is greater than or equal to 1. Okay? So let's go ahead and evaluate this limit. Now, before we get started, we need to take a close look at what we're given. Okay? We are looking for a double-sided limit. Notice there's no direction here, so there's an invisible plus or minus, which means left and right. We are looking for a double-sided limit of a piecewise defined function, and the value that we are approaching happens to be where the switch in the subdomain occurs. Okay? Whenever you have a scenario like this, you have to find the left and right hand limits. Why? It is because we have two different functions for the two subdomains that we have. You can't just pick one. Okay? Alright, so let's go ahead and write down the remark real quick that indicates what we're about to do, and then we will evaluate the limit. Okay? Alright, so since the limit as x approaches 1 of f of x is a double-sided limit, at the switch, a double-sided limit at the switch of the subdomains. So you're approaching an x value where you have the switch in the subdomains, In a situation like this, the left and right hand limits must be considered. Okay? So you gotta keep this in mind. Anytime you're looking for the limits that involves an absolute value function, and if the x value approaching is the same as the switch in the subdomain, then you have to consider the left and right hand limits to that x value that is being approached. Okay? Alright, so um, let's go ahead and start with the left hand limit. We're gonna call it LHL. Okay? The left-hand limit is basically the limit as x approaches 1 from the left. So the signed exponent of what x is approaching is how you indicate the direction of f of x. Now let's go ahead and give ourselves a visual of what is going on here. You don't have to draw the graph, okay? Now let's take a look at our subdomains. For x is less than 1, that's to the left of 1 on the number line, and then for x is equal to or greater than 1, that is to the right, and also the boundary. The boundary is included because of that solid line you have underneath the inequalities symbol. Alright, so what does this look like? Let's give ourselves sketch a number line. So let's say we have a number line like this. The switch in the domain happens at x equals 1. So let's mark that down. X equals 1. Alright, so when you're to the left of the of x, so everything that's less than 1, the function that's active is negative x plus 1. In the subdomain negative infinity to parenthesis 1, negative x plus 1 is active. And this is when you are approaching you're approaching 1 from the left direction. Okay? On the right side of our subdomain, including the boundaries, do you see the function that's active there? The function that's active is the second one, okay? So for any x value that starts from x and starts from 1 and goes to infinity, the function negative 2x minus 1 is active. Alright? Basically, when x is approaching 1 from the right, we are going to be looking at the function negative 2x minus 1. Okay, so you see why it's important to consider the left and the right limits when you're dealing with a situation where what you're approaching is at the switch in the subdomains, because you're looking at two entirely different functions. Okay? Alright, so for the left hand side, the limit as x approaches 1 from the left of the function, this is simply going to become the limit as x approaches 1 of the function on the left. Okay, the function to the left is negative x plus 1. Notice I didn't put any direction in what x is approaching. The reason is because I have already selected the function that x is going to be approaching, namely the function to the left. Okay? Alright, so using Sally, since we have a finite limit, we just substitute where x is approaching into the function. That gives us negative 1 plus 1, and our answer is 0. So that's the left-hand limit. Now, in order for the double-sided limit to exist, the right-hand limit must also be equal to 0. If it is not equal to 0, then the double-sided limit that we were asked to find does not exist. Okay? Alright, let's do it. So right-hand limit. The right-hand limit is the limit as x approaches 1 from the right of the function. And in this particular case, we're going to be looking at the limit as x approaches 1 of what? We're going to be looking at the limit as x approaches 1 of the function to the right which is basically the negative 2x minus 1 function. Alright, so to do this, we're going to use Sally again because we have a finite limit. What x is approaching is not plus or minus infinity. We have a finite limit, so we're just going to substitute. When we substitute, we have negative 2 times 1 plus, negative 2 times 1 minus 1. Alright, using order of operations, we have negative 2 minus 1, that's negative 3. Alright, so what is the double-sided limit? Is it 0 or is it negative 3? Well, since the left and right hand limits are different, the double-sided limit does not exist. Okay, so let's write that down. Since the limit as x approaches 1 from the left of the function, the left-hand limit is not equal to the limit as x approaches 1 from the right-hand limit, then the double-sided limit given by the limit as x approaches 1 of the function does not exist. Okay, so in shorthand we have the LHL, left-hand limit is not equal to the right-hand limit. Basically implies that the double-sided limit does not exist. Okay, so this, ladies and gentlemen, is the answer to question number 1. Alright, let's take a look at question 2. So for question 2, what if we are asked to find the limit as x approaches negative 1 of f of x, where f of x is a piecewise defined function given by negative x squared minus 2x minus 1 for the subdomain x is less than or equal to negative 1, and f of x is negative 1 for the subdomain x is greater than negative 1. Alright, let's do this. Now, what kind of situation are we dealing with here? It's a double-sided limit, and you notice that the value that x is approaching is the switch in the subdomain. So how are we going to approach the limit of piecewise defined functions that are presented in this format? Alright, so the procedure is as follows. Since f of x is a piecewise defined function, and the limit as x approaches negative 1 of f of x is a double-sided limit, okay? Is a double-sided limit. It's not just anywhere. This double-sided limit happens at the switch of the subdomains, okay? As a double-sided limit at the switch of the subdomains. What does this mean? This means that the left and the right hand limits must be considered, okay? Since it's a double-sided limit at the switch of the subdomains, the left and right left and right hand limits must be considered because we're looking at two different functions around that switch. Okay? Alright, so we're going to start off with the left hand limit. And then we'll do the right hand limit, compare our results, and see what happens. Okay? So for the left hand limit, we're looking at the limit as x approaches -1 of the function. Alright, so let's see, make a slight modification here. Let's see, x squared minus 2x minus 2. Okay, let me change that. Okay, so that's supposed to be minus 2. Alright, so let's give ourselves a visual to help us to easily determine what function is active where. X is less than or equal to 1. For that one, that is the left side because it's less than is to the left, and the boundary point. Okay, so if you're on the boundary, x is equal to -1 or to the left, this is the function that's active. To the right of that, x is greater than 1, this is the right hand side. Alright, so let's draw a number line to illustrate what's going on. The switch in the subdomains happens at -1. Alrighty. To the left of that, including the boundary, so -1 and everything to the left, what's active is the function negative x squared minus 2x minus 2. Alrighty. Now, if you're to the right of the boundary point, anything that's bigger than 1, -1, so -1 to parenthesis to infinity, the function that's active is the constant function -1. Okay, so this one is when you're approaching -1 from the right. So you're approaching -1 from the right. And then the red function is basically when you're approaching -1 from the left. Okay, so let's go back to the problem that we were working on. We're looking at the left-hand limit, so which function are we going to be working with here? So the left-hand limit is limit as x approaches -1 from the left direction of the function. This is the left-hand limit. So this is going to be the same as the limit as x approaches -1 of this quadratic trinomial that we have here, which is negative x squared minus 2x minus 2. Now to evaluate that, we're going to use Sally. We're going to substitute first and see what happens. Okay, so plugging -1 into the x's, we have negative times -1 square minus minus 2 times -1 minus 2. Now we're going to use the order of operations to simplify this. -1 squared is just +1, and then we have a minus in front, so -1 plus 2 minus 2 is equal to -1. So that is the left-hand limit. Now what do we do next? As indicated earlier, we have to find the right-hand limit, and then we're going to compare them, okay? So the limit as x approaches -1 from the right of f of x, what's going to be active in this case is going to be the constant function -1. Okay, so this is the limit as x approaches -1. We're not going to specify the direction, we'll just select the function that applies to this direction, namely -1. This is a constant function that's independent of what x is doing. It's always going to be -1, so this is equal to -1. So what does that tell us? Since the left and right hand limits are equal to -1, that tells us that the double-sided limits we're asked to find, limit as x approaches -1 of the function, is equal to -1. Okay, this is since the left-hand limit was equal to the right-hand limit, and it was equal to -1. Alright, so that's the reason why we're able to arrive at the conclusion that the double-sided limit is equal to -1. Alright, let's take a look at question 3. So for question number 3, we're going to look at a piecewise defined function presented in absolute value format, okay? So limit as x approaches 1 from the left of 2 times the absolute value of x minus 1 over x minus 1. Alright? So this is not a double-sided limit. This is a one-sided limit. So that's going to be a little bit easier to handle. So limit as x approaches 1 from the left of 2 times x minus 1 over x minus 1. Now, what we're going to do is we're going to rewrite this absolute value component. Okay? Limit as x approaches 1 from the left. Now, for the absolute value component, if you look at the quantity inside the absolute value, it tells you what the switch in the subdomain is. Alright, inside the absolute value we have x minus 1, just say that equal to 0, so for x. So you can see that the switch in the subdomain occurs at x equals 1. We are approaching the switch in the subdomain, but we're approaching from the left side. Okay, so if we want to rewrite this function, we're going to write it as plus or minus 2. So replacing the absolute value, parent brackets with plus or minus x minus 1, and then just multiply by the 2 that was there before, divided by x minus 1. So the question now is, which sign are we going to pick? The positive sign or the negative sign? Well, for the absolute value function, since you're approaching from the left, you're going to pick the negative sign. Alright, so we're going to have the limit. This becomes the limit as x approaches 1 of -2 times x minus 1 over x minus 1. If we were approaching from the right, we'll pick the positive sign. Okay? So for absolute value scenarios, if you're approaching the switch in the subdomain, just follow the direction. Left is negative and right is positive. Alright, so these x minus 1s divide out. And now this becomes the limit as x approaches 1 of -2. And then our final answer is going to be -2 because it's a constant function that's independent of where x is going. Okay? So there goes your answer. Alright, so how well did you understand the contents of this presentation? To demonstrate mastery, we would like you to try out the following problems. So try these. So what you're going to do is copy down the problems, pause the video, work on them, and then when you're done, just initiate playback to see what the answers are. Okay? So evaluate the given limits. Question 1. What if you have to find a limit as x approaches -1 from the left of f of x, where f of x is the piecewise defined function given by -x over 2 minus 7 over 2 for the subdomain x is less than -1, and 2x plus 4 for the subdomain x is greater than or equal to -1. For number 2, what if you're asked to find a limit as x approaches 0 of f of x, where f of x is a piecewise defined function given by -2x minus 6 for the subdomain x is less than or equal to 0, and negative x squared minus 4x minus 3 for the subdomain x is greater than 0. For number 3, what if you were asked to find the limit as x approaches 1 from the left of the of 5 times the absolute value of x minus 1 over x minus 1. Number 4, what if you were asked to find the limit as x approaches negative 3 of 2 times the absolute value of x plus 3 divided by x plus 3. Alright, so go ahead and pause the video and try out these problems. When you're done, click on play to see what the answers are. Alright, so hopefully you had a chance to try out the problems. The answers to the problems are as follows. For question 1, the answer is negative 3. For question 2, the limit does not exist. For question 3, it's negative 5. And then for question 4, the answer is the limit does not exist. For this one, you're going to have negative 2 from the left of negative 3 and then positive 2 from the right. So the answers are different. So that basically means that the double-sided limit does not exist. Okay, in this part, number 4, you actually have to do left and right hand limits since the direction is not specified. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of limits, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered or the problems that we presented, I'll just put it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the remainder of this virtual text series. More tools, videos, worksheets, and games can be found at our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.